Welcome to the Rotational Motion and Accelerating Fluid Lab. In this experiment, you will be calculating the angular velocity and acceleration and comparing them to directly measured values.
Plug the photogate into the digital port 1 of the interface. Plug the motor into the signal generator ports.
Put some water in the container, leaving plenty of room to avoid spillage. Place the container on the rotary platform and use the Allen key to tighten it.
On the computer, open Capstone. Click on Hardware Setup, select Digital Port 1, then Photogate with pulley.
Close the hardware setup and drag a digits display onto your page. Click Select Measurement and choose Angular Speed in radians per second. Press Record, and once the system is in motion, the display will begin to show data. To accomplish this, click Signal Generator. Change the waveform to DC and turn on the output. Adjust the voltage as needed.
Measure R, the radius of the container, Z, the height of the water at the edge of the container, and Z0, the height of the water at the center of the container. These will be used to calculate omega, the angular speed. Compare your value with the one measured directly in Capstone.
Replace the round container with the smaller rectangular one. Again, add enough water to see the effect, but leave plenty of space to avoid spillage. Increase the speed until there is no water at the center of the container. Measure x0, the distance from the edge of the container to where the water meets the base of the container, and y0, the height of the water at the edge of the container.
Use these values to calculate A and compare them to A primed, which is calculated directly from the values measured from the interface. Repeat both sections for different omegas.
Thanks for watching the Rotational Motion and Accelerating Fluid Lab, and remember, don't use hyperbole to describe your parabola.